I'm just going to coordinate with marketing to make sure that we're on. Are we on? All right, looks like it's loading on their end. Just gonna check out the YouTube page real quick. They're still not seeing anything. So it does say that we are live, which is interesting. Yep. Oh. Sorry for the delay here. I'm not sure what's going on. This usually is much quicker.
No worries.
Just gonna double check my Zoom settings. Live streaming. Get the key matches, stream URL. Oh, it says it's private. Oh, okay. Maybe I put the wrong stream again. That should be it. All right, well, I guess we're going to continue on this private stream. And then people will be routed over here. Looks like we already have viewers. So that should be fine. They are unfortunately being exposed to the live stream boiler room, but it's okay. Let's get right into it. I'll keep communications open with marketing in case anything else happens, but we should be good to go.
Cool.
All right, let's do this. So everyone, welcome to today's workshop. We'll be going over how to build with Superfluid and Lens with Nader Dabit from Lens Protocol. Really excited to be here today. We've been talking about the possibilities of integrations between Lens Protocol tooling and Superfluid monetization. And so this is going to be a fun workshop where we go over a simple project that integrates the two technologies. So yeah, I'm Sunny. I'm from Superfluid Developer Relations, and welcome, Nader.
Thank you for having me. First time I've used Superfluid has been in the last couple of weeks, but it's been a lot of fun. And I think that it's a really cool workshop for us to kind of go over combining both Superfluid and Lens. And I think that after using it, I'm pretty excited about building other stuff with it. So hopefully other people will be too.
Sweet. All right, so before we go any further into like coding and everything, I want to make sure that people have a good understanding of what Lens Protocol and Superfluid are. So I just want to quickly pass it over to Nader to just give us an introduction into Lens Protocol. Yeah, so how would you like to do this, Nader?
Yeah, sure. So Lens is kind of a very general overview of what it is. It's essentially like the social layer of Web3, but for developers, it's a suite of like APIs, SDKs, and tools for building social applications or social features into existing applications. And I think it's really important because there are 4.9 or so billion people in the world that are using social applications today. And with blockchain and Web3 technology, I think that we've been, really looking for the use cases that are attractive to the average person. And beyond payments, I think it's been kind of tough for a lot of like Web3 apps to figure out like where they can reach a large amount of users. And with use cases that are familiar to people already, it just becomes a lot easier for them to kind of onboard into Web3. And then from there, they might be able to start exploring other parts of Web3. So maybe they would start using DeFi and stuff once they have their wallet set up and things like that. Or once they're kind of just familiar with being essentially quote unquote like on chain. So what Lens tries to accomplish is offer a really simple infrastructure layer for building out social applications or social features. And a good example of like what this might look like is obviously things like TikTok and YouTube and Twitter and all of these really, really popular applications today are all either social apps or they have like a lot of social features built into those apps. But, when you start actually looking into a lot of other applications that you might not consider social apps, you start realizing that this type of functionality is built into a lot of the applications that we use. So for instance, GitHub is a good example of an app that you might not consider a social app. But once you create an account and you start following other people and you start realizing that you're shown a feed of activity, you can start using it kind of like a social app. And when you start looking at other applications that are out there, you start realizing that this type of functionality is built into so many applications and it offers a lot of value. So when we built Lens, what is essentially one of the main focuses is abstracting away a lot of the complexity for building out these features and just making it really simple to use. So when you look at an example of this in the Web 2 world, you need certain features to build out almost every application. You need like a database, you need an API, you need authentication, et cetera. What's happened over the last 10 or so years is cloud providers and other software as a service providers have started offering what might be like called serverless or managed services to accomplish a lot of this functionality so developers don't have to build it themselves from scratch. So you have Auth0 for authentication, you have serverless functions for functions or for execution. You have Twilio for sending messages and making calls and stuff like that. What you could think of as Lens is essentially like a serverless or a managed infrastructure for adding social features. And there really doesn't exist anything like this in the Web 2 or the Web 3 world. So we're seeing a lot of like traditional Web 2 developers become interested in working on Web 3 in this capacity, because our APIs and SDKs are kind of really focused on non-blockchain developers. So that's kind of a general overview. There's like a lot of activity happening right now in the bear market in the Lens ecosystem. We have a lot of companies that are raising money successfully. We have a lot of successful apps. We have a lot of excitement still, because I think, again, it just provides a use case that a lot of developers can identify with, and also a lot of users can identify with.
Sweet. Yeah, that was great. The Lens ecosystem has been incredible. I routinely use Lens for myself, and yeah, I think the focus towards letting developers build things with immediate utility and not so much kind of like gated by the sort of restraints of Web3 has been really cool to see things come up with Lens Protocol. So thanks for the intro there. I'm going to take things away and just introduce what Superfluid is. So Superfluid at the base level is an EVM-based smart contract framework. We allow you to do something called money streaming, and you can kind of see a small visualization of that there with that little graphic. And basically, money streams are continuous per second payments that you're able to do and basically send money at a per second almost flow from your account to another account. And this money, it comes in the form of super tokens being this additional kind of token standard that we've introduced at Superfluid. And with money streams, you're moving tokens at a rate at a per second basis instead of in kind of discrete lump sums. For instance, when you transfer tokens, you are moving things in discrete lump sums. You're saying, I'm going to send you 10 DAI. With Superfluid, you're able to say, I want to send you like 0.001 DAI per second. So that's what Superfluid is kind of like best known for. We allow this to be done with no delays, no payment risk, and no intermediaries, thanks to the instant settlement layer of the blockchain, because we are a smart contract framework. So just to kind of like get deeper into that concept, the way we've always experienced money has been the basic transfer. Let's say I Venmo you $10, my bank account is basically reducing by 10, and your bank account is increasing by 10. And this is kind of exemplified in the ERC20 token standard, where transfers are done, and it's simply that plus minus kind of transaction that happens there. With Superfluid, we're taking this a step further with money streaming, where you're basically able to say, instead of I want to send you, $10 all at once, I can say I want to send you like $0.004 per second, and that'll come down to like a monthly rate of $1,000 per month, and you're able to send these little bits of tokens per second from your account to another, and basically move money continuously until you either stop that stream or you run out of tokens. So that's the idea of money streaming, and it literally moves tokens on a per second basis. So if you were to check your balance, you would see that it's changing every single second. So at the end of the day, Superfluid is simply a smart contract framework. We're basically taking the ERC20 token and we're extending it to do more functionality. So you can do everything you can with Superfluid super tokens, from transfer, like that you see with ERC20 tokens, such as transferring, such as approving for spending. And you can also do the additional Superfluid stuff, such as money streaming. There are additional things such as instant distributions that we permit. You can approve another address to start streams on your behalf, just as you would approve another address to transfer on your behalf with the ERC20. And so Superfluid at its base level is designed as a DeFi primitive, so that it can be integrated very easily with. So it's ultra composable, and we believe in the idea of money Legos, right? So it should be able to be composed in a very kind of easy fashion. And I'm just going back here. When I say how easy it is, the experience of building with Superfluid is akin to building with ERC20 token, just as you would call like token.transfer, you can call supertoken.createFlow. And the experience is meant to be kind of intuitive and comparable to what you see with traditional token development. And so when it comes to monetizing your content and the way that Superfluid is relevant with Lens Protocol and Web3 social, we see a lot of ways that monetization happens in the kind of traditional social media world or overall media world, right? We see that with advertisements, subscriptions, affiliate marketing, e-commerce, etc. And so being able to kind of take that sort of monetization framework from the real world that we see and apply that to Web3 and make it scalable. Superfluid's payment framework is really good for that. And so we're going to see how we can build things with on-chain continuous payments and apply that to Web3 social during today's workshop. So what are we going to be building? Let's give a little teaser to that. So we're going to be building something called the Lens hashtag rewarder today with Nader. Basically, the idea here is to use the Lens subgraph to understand what people have posted with a specific hashtag. Once we can query that off the Lens subgraph, we can begin to start streams of per second rewards to each of those accounts that have posted with that hashtag. And we're able to actually start all those reward streams at once using something called the Superfluid batch call, which allows you to bunch together a bunch of Superfluid transactions or Superfluid function calls, in this case being grade streams, and execute them all at once. And so here we're kind of like creating a cool mechanism where you're able to incentivize people to post with a specific hashtag continuously, as opposed to one-off payments. So yeah, that's the whole idea for today. And without further ado, let's get to building. I'll turn it over to Nader.
Hey, yes. So by the way, the app that I built is a little different than that. The app that I built basically allows you to sign in with Lens. It'll pull like a follower graph for all of the people that are following you. And then you can basically choose one of your followers to reward. And then one of the things that I'm going to be adding later today is a way to kind of like sort by the number of followers. So if you have like a large number of followers, you can kind of like filter by those, and then you can kind of like reward your followers. So it's more of like a basic example, essentially, I would say. But I think it's really a better reference architecture for developers that are getting started, because it shows how to put the simple pieces together to build out like maybe more complex stuff. The code is something that we can actually cover, I think, in this, in this few minutes that we have.
Absolutely. That sounds great.
Okay, cool. All right, so I'll go ahead and share my screen, I guess. Let me organize stuff real quick a little bit. I like how we can choose a portion of our screen with Zoom, because some of these other like streaming software doesn't allow that. Okay, cool. All right, so what we're starting off with is a basic Next.js application, and I'm going to go ahead and run that in a second. But before I do, I want to show you an example of like the finished application that we're going to be building. This is the app here, and right now we're not connected. So what I'll do is connect, essentially like you're signing in. So I'm going to connect my wallet. This will pull my follower graph from Lens. And what we would like to do is that we would like to click on one of our followers, and then we want to set up a stream, and then we want to view that stream in the Superfluid dashboard. The code base for this is located at GitHub/Dabit3. Wow, it looks like GitHub changed their UI a little bit. Anyway, so if you go to my repositories, you'll see Lens Superfluid here at the top. It was just pushed up there recently today. And all of the code that we're going to be covering like it's here, and this is probably a good starting point, I think, boilerplate to build out a Superfluid app with Lens, because it has all of the dependencies that you might need to kind of get started. And then this is an example of the Superfluid dashboard. And what we are essentially hoping to do is, like, after we create our stream, we want to come here and be able to kind of view that stream here live. And to start things off, I have created a basic Next.js application that I'm going to go ahead and run here, just to show you that we're indeed starting off from scratch. So if I go back to localhost 3000, and here you see that we're kind of starting off from a brand new app. So I think the first couple of steps we might want to do would be to connect our wallet, and then also to connect to our follower graph on Lens. And to do that, we're going to need a file to talk to the Lens API. So I'll create a file called api.ts, and this is going to be how we connect to the Lens API. And I'll go ahead and import a couple of things here. We're going to import, well, actually, a couple of things from Apollo client. We're importing the Apollo client, the in-memory cache, and the GQL helper, which allows you to kind of take strings and turn them into GraphQL queries. And I guess before going into that, I'll just go over the few dependencies that I installed here. I installed Apollo client. I installed the Superfluid SDK. I installed Ethers, and I installed GraphQL. So those are the 4 dependencies that kind of we have installed to get this all working. Next, we're going to create a GraphQL client, and this is going to allow us to connect to the GraphQL API. And we're going to have 2 queries. One is going to be to get the profile for the signed-in user. And this allows us to pass in the Ethereum address of the wallet that's connected and return the profiles that that wallet owns. And essentially, we're going to take the first wallet, or the first profile from that. And then the other query that we're going to run is the get followers query. And this query gets the followers for a profile ID. So we'll call these 2 back to back. So when the user connects their wallet, we'll get the profile for that wallet, and then we'll get the followers for that profile. And then using that, we can populate the Superfluid stream. All right, so if I go to page.tsx, you'll see that it's already populated with all this boilerplate code, which again looks like this, but we don't want it to look like that. So what we'll do is just delete everything starting off. Whoops. And then all we have to start off with is this blank page, which should be empty now. And I'm going to go ahead and say use client, because with the new version of Next.js, we need to define that this is a client-side route. Next, we're going to import some stuff from React. So we're going to import use state and use effect. We're going to import ethers from ethers. And then we're going to import the Superfluid SDK. And then finally, to talk to our GraphQL API, we're going to import the client and the 2 queries. So these are all the imports that we're going to need for the entire app. And I think one thing I need to actually do is update the version of Ethers, because I think the new version of Ethers might not work, if I remember correctly, with Superfluid, at least in the example that I have. So I'm going to drop this down to 5.7.2. I'm just going to do another npm install or another yarn. Make sure that we have the proper version of Ethers installed. Okay, cool. So now that we're have all of our imports, we'll do one basic declaration for TypeScript, so it won't argue about window.ethereum, and then we'll go ahead and start creating our main code base. So we're going to need a couple of pieces of state. We're going to go ahead and set some initial state for the current account, which is going to be the account that is going to be set for us to send to Superfluid in a moment. And then we're going to be able to set that account. We also want to get a list of profiles from Lens Protocol, so we're going to set that. We want to set the flow rate display and a function to kind of update that. And this is going to be the display value of the actual flow rate. And the flow rate is going to be essentially the stream that we're sending to Superfluid, I guess, or through Superfluid. So we have the flow rate and the flow rate display. And then we're also going to set the recipient. Let's see here. Okay, actually, so the recipient is going to be the address that we're sending to, and the account here is going to be the account that's connected. All right, and then we're going to have a function just to connect our wallet. So connect wallet is just going to use window.ethereum to connect the user's wallet like we saw just a moment ago. And then we're going to set the current account, and then we're going to call a function called fetch followers. And this is going to be the function that talks to our GraphQL API. And this function has a decent amount of code. So I'll go ahead and copy and paste this here. So fetch followers takes in an account. We call API, the GraphQL API for Lens. It returns the profiles, I would say. And then we get the profile ID from the response there. And then we call the API again to get the followers. So we make one call to get the profile for the signed in account. Then we make another call to get those followers. And then we're going to basically filter for any accounts that have a default profile. This is more for just this example because we want to only show profiles that we can actually get their Ethereum address so we can send the stream there. And then we're going to kind of change that object for the profile, and we're going to add their address, and then we're going to filter to only return profiles that have a picture. So we're kind of like taking the data that comes back from Lens and we're munging it a little bit here just to kind of make it work well for this quick tutorial. So it shows up, in a nice way in our user interface. What I'm going to also do is go to tsconfig, and I'm going to set no implicit any to false because I'm not doing everything type safe here. So those errors should go away. All right, so we have our connect wallet. We have our fetch followers. We also want to have a function that will check to see if the user is already connected. And this isn't like 100% necessary, but it provides a better user interface, a better user experience, I would say maybe. So when the app loads, we want to just essentially check to see if their wallet's connected. And if it is, we want to go ahead and connect them. So this is going to look for the window.ethereum object. And if we can get the accounts, we go ahead and set that account. So it would be as if we connect once, and then when we come back, the account that it was connected before just stays connected. All right, so we have the connect wallet function. We have the check if wallet is connected that will call when the app loads, and we have fetch followers. None of this is really Superfluid yet. This is more just setup. And then in our use effect hook, which is what will invoke right when the app loads, we're going to call check if wallet is connected. So this will automatically just check to see if the user's connected, and if they are, it will show that. It'll essentially go ahead and set the local state and everything like that. All right. And then what we want to do is we want to show a button that will render only if they are not connected. And then maybe we'll also have like a headline. So we'll say like an H2 or H1 maybe. We'll call this like superfluid lens. Of course, using these. There we go. And we'll say if there is no current account, we want to show this button to connect the wallet. And if there is a current account, we want to show that account. And this is just, again, basic setup for us to get started. So this should provide enough functionality for us to go ahead and connect our wallet. So if I run npm run dev here, I know this is very small on my terminal, so maybe I'll just bump the size up there. This isn't really that important. We should be able to go here. And let's try running this again. Oh, it looks like we already had it running. Okay, cool. But still, I think that we might have some issue. Okay, cool. So it looks like it's already signing us in. And I think that's because we were running a similar app earlier. So what I'm going to do is just disconnect. And we see that we have our connect wallet button. And what I'm going to also do is remove the CSS for the minimum height. This makes it just look a little better. So if I click connect wallet, we're connected and we show that we have our address there. So now we can continue on. So the next thing we might want to do would be to render out or render all of the profiles that are associated with our followers. And this is just some user interface for us to have to be able to kind of view our followers and then add them to the Superfluid stream. And in order to do that, we're going to need one helper function that's going to look at our Lens followers, and it's going to extract the profile picture from the URI and form like a gateway endpoint. And if you've ever used IPFS or Arweave, you know that it kind of often will come with just a hash. So it'll be like AR:, or it'll be IPFS:. What this basically does is it takes that and turns it into a gateway endpoint. So it just replaces that with an actual gateway endpoint. So nothing really crazy going on there, just a nice helper, because that way we can show the user's profile picture. And then what we're going to do is we're going to map over the profiles, and we're going to render like a small display visually of the profile. So this is going to be a fair amount of code that we're going to walk through. But really the main thing that's going on here is this profiles.map. We're like mapping over the array. We're going to return the profile picture image. We're going to return the profile, like user's name and their profile handle. And what we're doing in these three checks here is that there are a couple of different types of profile pictures that people have on Lens. You can probably extract this and format the data like when you call the API. Here we're doing it in the UI. And like if someone has like an NFT profile picture or maybe a different type of profile picture, it'll show up differently here. So what we should be able to do is now go back here and see that we have our followers list here. So we have all of our Lens followers coming back. And what we want to do now is be able to essentially like click on a follower and then be able to set up a Superfluid stream. Now you'll look here, we already have an on-click handler that's calling this set recipient. And this will basically set the, like obviously the recipient for the account that profile is associated with. So this will go ahead and set that state. So what we might want to do is have like a text input or some way to kind of like view that state. So we have set recipients. So what we might want to do is, yeah, we can either set this like this. We could say, whoops, recipient in. But in our case, we're just going to have like a text input, but because this way you'll be able to pass in either like manually an address or just click on an address. So we have a div here, and this is going to essentially be our form. So this is going to be the recipient. And then we're also going to have an input for the amount of like tokens we want to send that user. So we have an input, like a input for the recipient address. We have an input for the amount that we'd like to send them. And then we'll have a button that will create the stream. And then we have some functions that we still have yet to actually write. So handle recipient change, handle flow rate change, and create new flow. And then what we want to have is a quick button to just allow us to navigate to the Superfluid dashboard. Because after we create a flow, we want to go and view that flow. And then finally, we want to show the Superfluid amount that we're going to be like sending to that person. So this will basically calculate the amount, and it will say you're going to be sending this much Matic per month. All right, so what we want to do now is create those three functions. One is handle recipient change. This is a pretty basic function that's just going to be essentially an on-change handler. So I'm going to minimize that. Handle recipient change will just set the recipient with the event.target.name. Handle flow rate change will be a little bit more complicated, but not really. We're going to basically set the display flow rate, and we're going to set the flow rate. The display flow rate is essentially the flow rate turned into a string. And then we need a function to actually calculate that flow rate. Oops. We already have it there. All right, so this basically will take the amount and use some utilities from Ethers and format that to something that we can actually use in our app. And I think we have one more function that we need to create, which is the actual function to call and create the flow. And this is going to be where we talk to Superfluid. So this is going to be the most like Superfluid code that we've written so far, I guess you could say. But this is also going to be like the most important for you to understand how like this all works. And will also be like the largest function that we've written so far. So I'll minimize a lot of this stuff here. And I'm going to create a function called create new flow. And it's going to take in two arguments. One is the recipient and the other is the flow rate. Up here, we're basically just getting the wallet that the user is connected with and creating a signer using Ethers. Actually, here, using Ethers. And then we're going to create a variable called SF for Superfluid. And this is going to be how we configure Superfluid. And this is going to be us saying we want to use Polygon because we're setting the chain ID as 137. And then obviously you could kind of set this to whatever you like if you would like to use a different chain, or you might have like a drop down that allows someone to populate this themselves. But we're just hard coding Polygon here. We create a superfluid signer by calling superfluid.create signer, passing in our signer. And then we load the superfluid Matic token. Now when you're working with superfluid, you're not using just regular tokens. You have these X tokens, I guess is what they call them. So you need to kind of like have some of these tokens essentially in order to be able to send them to people, I believe. So I went to the dashboard here at app.superfluid.finance, and here you can wrap and unwrap tokens. And this is how you can get those tokens. So really one of the main places to go poke around is this superfluid dashboard at app.superfluid.finance. All right, going back here. All right, so we have our signer. We've defined the type of token that we want to send. And then this is going to be where we actually create that transaction that will initiate the flow. So we call Matic x.create flow. We send in the sender, the receiver, and the flow rate. And then that's really it. Like if this is successful, we'll have to sign or actually like pay for this transaction. And if this is approved, then we should then immediately be able to go into the Superfluid dashboard and see this happening in real time. One other thing that I'm going to do though is like change the CSS here a little bit because it's very like narrow. So let me see what I can do to fix that to make this look a little bit better. I'm always unsure. There we go. All right, so now our application is becoming more complete. We have, let's see here. Looks like I've mapped over something and repeated something that shouldn't be repeated. Okay, yeah, I put the form in the wrong place. So let me move that real quick. Give me 1 second. I think this is what I need to move. There we go. So I'm going to move this right here. Try that again. All right, there we go. So we have our list of followers. If we click on a follower, we should be able to see that their address is populated here. So I see I have live here following me. I have bigboss.lens. Let's see who else. So Jessie Fries, so she's a very big content creator on Lens. So let me send her a stream. So I've clicked on her address and it's been populated here. And what I want to now set is how much way I want to send her a second. So this is going to be something like, I'll say this amount here, like 1 and a bunch of zeros. I don't know exactly the amount, but this comes out to be 2.592 Matic a month using the calculation that we set in our code. So that's pretty simple to view. And maybe I'll just add another 0 to that. So make it $25 a month. And if I want to create the stream, I can click to create your stream. I'm going to confirm that, and then we'll wait a couple of seconds to see if this is confirmed. And then we'll go here to the Superfluid dashboard. And let me see how this transaction is going. Okay, cool. It looks like it's confirmed. So if I refresh here, you'll see now that I have actually some movement happening here. We see now that we're streaming tokens to Jesse Fries, and the flow rate is 26.28, which is the same as what well, it's not exactly the same, but it's pretty close, I guess, to what we had there. Obviously, I guess with Matic price changing and stuff might have affected that by a tiny amount. But that's kind of it. Like we've essentially built out a pretty basic app where we're listing all of the Lens followers that we have, or not all of them, but a lot of them. We're able to kind of click, create a stream to some of our followers. And if we want to stop the stream, we click this cancel stream button. This will allow us to like confirm that cancellation. And then once that's done, the stream stops. The code for this, again, is located at github/Dabit3/Lens-Superfluid. So one thing I'm going to add to this is going to be an API that allows you to pull the followers with the most followers they have themselves and filter in that way as well. So you can kind of see the most high signal people and then maybe reward them instead of just a regular query for your followers. So I'm going to go ahead and stop sharing my screen here. All right. I'm back.
Awesome. No, that was epic. I think, yeah, like typically when we think about like rewarding followers, I picture like, one-off payments. I think the best way to think about it is like, okay, I want this person to keep following me and their kind of connection to me is valuable. And that's a continuous thing. So it makes sense to kind of reward it continuously. And I think this application just showed a concrete, simple, way to do that. So really good stuff there. I could see like plenty of ways to extend this. Like you said, being able to view your followers on a kind of like influential basis based off how much followers they have themselves, and being able to start streams accordingly. Perhaps there could be like an automation mechanism in there that'll detect when someone unfollows you and stops your stream to them. Tons of ways that you can take this, guys. So if you're looking for a hack for this wave, definitely, take this as inspiration and, build off of it, because I think it's a great kind of, base concept there. So
yeah, and I think like it would be really valuable is being able to kind of surface this like in one of the main Lens UIs, or building out your own app that like really makes this kind of like a highlight. Because like if you look at Twitter and YouTube and a lot of these apps, they're going to this model where you're kind of like super following someone or whatever. But this is just a different take on that. And I think like being able to kind of show that you are rewarding like certain followers or you're being rewarded as a follower is like a cool signal to have out there. And there's a lot of cool stuff that you can do to kind of like surface that in an app that hasn't really been done yet. One thing I want to call out is like there is a really great document. I don't know where it is, but maybe you can point to it that you all created that has a lot of really great ideas for the hackathon. I think most of those are doable in like a week. I mean, obviously it's not going to be the most polished thing in the world, but like I think using this like code base that we start off with, you can probably accomplish something and get like something across the finish line in a few of these domains. I was able to build this app in a few hours. So like if I'd spent a week or two, I can't imagine what I could have done with it. So the document that he has a lot of really great ideas that we'd love to see. And if you were able to build that, like after the hackathon, we'd love to talk to you about getting a grant or something like that.
Yeah, I love that. I did just drop that link to the idea material in the YouTube chat. Yeah, it's full of good stuff. And also, I do want to call out one little thing towards the end of the workshop. 1 second. Yeah, so what Nader was streaming there was super tokens, right? So he was streaming Matic X. That's a wrapped version of Matic that is able to be streamed with Superfluid, right? You can't just stream plain Matic. You have to stream the wrapped Superfluid version of it, which we refer to as Super Matic. Just something to bear in mind as you guys kind of approach building with Superfluid. You're not kind of like building on top of regular tokens, you're building on top of Superfluid's extended version of them, which are often wrappers. So yeah, that's something I wanted to call out there. And yeah, what else? Looks like we got a couple of questions in the chat. Couple from Bruno. Bruno, I've seen you building on top of building for this wave, and you've been putting together some really awesome stuff. So good questions here. Let's start off with the first one. How the gated posts work. Can you explain more on the cryptography side and talk about the EOA criteria? So I think this is in reference to the gated publications functionality that Lens offers. And I think the fact that you're able to set it up such that decryption only happens if you possess a certain ERC20 token or a certain NFT.
Yeah, okay, so I'll just give an overview of how it works now. It's using Lit protocol, and there's a lot of different methods that you can use to decrypt. So there's like an and or an or policy. An and policy would say, like, you have to have this and this and this. An or policy would be like, you can have this or this. So you might say, if you are a developer DAO token like holder, or if you have like 100 Matic, or if you've done this or if you've done that. So you can kind of string together a lot of different like situations that you might allow someone to decrypt. But for something like Superfluid, you might have to build out something custom, I believe, maybe, because like by default Lit protocol, the way that from what I understand that it works, it wouldn't support something like a stream. But it might be something for us to kind of look into supporting natively. But this would be something that you could probably build yourself using Lit protocol. But it would just be more of a custom thing.
Gotcha.
Yeah.
Yeah, I think. Oh, go ahead. Oh, sorry. Yeah, that's cool. I think I also kind of touch on the way that you can implement this with Superfluid, such that you can make like an NFT that only returns a balance of 1 or 0 if you're streaming to a certain address. And so you can kind of fool this gated publications feature into giving access or not based off of the existence of a certain stream to an address. I kind of touch on that in the Hack Ideas page there. So that's there to kind of
nice.
provide more details. I also want to answer your second question, Bruno. So on Superfluid, super tokens, when the stream finishes, do you burn the NFT/token from the user that was streaming? So I think this could be referring to two things. I'll attack one of them and then perhaps get to the other one. The NFT that you may be referring to is the existential NFT that Superfluid protocol kind of mints when you start a stream to someone, kind of like akin to Uniswap, LP NFTs. So these NFTs, they're existential. So you're right. Like when you're streaming to someone, that stream, you get that NFT, and when you stop streaming or you modify your stream to a different flow rate, that NFT either disappears or its metadata changes based off the update to your stream. So yeah, and then like perhaps to answer your question from another angle, your stream will only go on until you can either cancel it or you run out of super tokens and you kind of like exhaust the amount of tokens that you can stream. So yeah, that's that. Does that kind of make sense? Feel free to let me know in the chat. But it looks like that's all for questions for today. So if there are no more, I'm just going to share my screen again and we can wrap things up. One second while I do that. Go. Slideshow. All right, so again, everyone, this workshop was in honor of the Superfluid Wave Pool. The Wave Pool is our continuous hackathon. It's iterating every single month. But this month we have a Wave Pool out with the Lens partnership. That's why we're doing this, because we have around $10,000 worth of prizes for projects that are building on top of Superfluid and Lens for this Wave Pool. And so if you're looking to dive in, you can go straight to superfluid.finance/wave-pool, and you'll find all the information you need to get up and running with your Wave Pool project. Again, this is a month-long hackathon, so this June wave, it ends at the end of June at 11:59 p.m. Eastern time. And so you have up until then to, if you haven't already, start a project and submit it. And then right after that, another wave will start with July and August and so forth. So it's a kind of a cool repeating hackathon concept. So that's what this is all about. And yeah, just get in touch if you guys have any questions. I'm at Sunny Jaycer, and Nader, if you somehow don't already follow him, is at Dabit3. And yeah, if you want some more support, you can hop on discord.superfluid.finance, and we'd love to kind of help you out with any questions you may have. As well as in the Lens server, you guys are great with technical support there as well. So yeah, that's it. That is a wrap for today. Thank you guys so much for coming out and hopefully learning a thing or two at this workshop. And Nader, thank you so much for coming out, man. Like, I know it wasn't easy with all the travel and everything, so really appreciate you coming out here and teaching us today.
Oh, happy to be here. Thanks for hosting and putting together hackathon. I'm really excited to see what comes out of this.
Sweet. All right, guys, enjoy the rest of your weeks.